Okay, now we're recording. Alrighty. So these things are called relations, right? And in order for it to be a function, function means that the x values are going to be faithful, okay? Like a relationship, right? So think about like couples. In order for this to be a function, everybody here has to be faithful. None of these people can be cheaters. So if you notice here, look, 2 hooks up with 1, so 2 is not cheating. 5 hooks up with 1, 5 is not cheating. I know that you might say, well, look, 1 is cheating. That's okay. For functions, the people that have to be faithful are the people in the domain, okay? So 2 is good, 5 is good, 11 is good, 17 is good, and 3 is good. These people here cannot cheat in order for this thing here to be a function. These guys over here, yeah, they can hook up with multiple people. But the people in the domain are going to be faithful. Okay, they can't be hooking up with anybody more than one, right? And so it's asking us if it's a function. So we're going to say yes, it's a function. And then it's going to ask us for what's the domain, okay? So the domain is just the numbers that we have right in here. So my domain is going to be the numbers 2, 5, 11, 17, and 3. And then the range are the second set. So the range is just the numbers 1, 7, and 10, okay? So when I think about these kind of circles, that's how I figure out if it's a function or not, right? So when I come back and I look at, say, like this problem here, we can do the same setup, right? We can say, look, let's draw 2 circles, 1 and 2. And the first numbers are going to be the numbers that go here. So, and if they repeat, guys, I'm not going to put them twice. I'm just going to leave them one time. So I have 1, 0, and 2. And then the second numbers are going to be the numbers that are going to go over here. So 1, -1, 0, 4, and -4. And then now all I'm going to do is I'm going to draw my arrows. So look at the first one. 1 hooks up with 1. The second one says 1 hooks up with -1. The third one says 0 goes to 0. The third one says 2 goes to 4. And the last one says 2 goes to -4. So now we're going to ask ourselves, are these guys here hooking up with more than one person? Yeah, they are, because 1 and 2 are. So as long as you can find one of them that's hooking up with more than one, it's not a function. So right here, we're going to say not a function. Okay. But my domain, because relations also have domain and ranges, so the domain is still the same numbers, 1, 0, and 2, the first ones. And the range is 1, -1, 0, 4, and -4. And so, guys, when I'm going through these problems here, again, I like doing it this way because it's visual and you can kind of see what's going on. But if you don't want to do that, the shortcut would be check to see if the x values repeat and the y values are different. So yeah, look, the x values repeat and the y values are different, right? So if I were to do that for the next problem, and I were to say, well, look, if I don't want to draw the picture, do the x values repeat and the y values are different? Yeah, those right there, right? So we could automatically say this is not a function, okay? But the domain is still the set of the x values, so 2, 3, and 5. And then the range are the numbers 5, 7, 9, and 11. Okay, so before I go on to this next problem here, let's see. I want to make sure, let's see, is this making any sense? Do you know how to determine if something is a function? We all think. Yeah, we're doing okay so far? Okay, perfect. Just checking with you guys, okay? So guys, if you have questions, please don't be shy to ask, right? I'm here to help you guys. Okay, same thing here. Look, you can kind of think of this. This is already set up, right? 0 goes to 0, -1 goes to 1, 2 goes to, or -2 goes to 2. So yeah, we got a function here. My domain is just the numbers 0, -1, -2, and our range is 0, 1, and 2. Okay. All right. Now, there's something called a vertical line test. So we're still trying to figure out if something is a function or not. And if it's a function, the vertical line test says we can draw a vertical line. So guys, just a quick reminder, vertical lines are lines that go up and down, right? And if the line hits it more than once, it's not a function, okay? If it only hits it once, it's going to be a function. So if you notice here, if I draw a vertical line going up and down, I only hit the graph once. Every time I do that, I'm only going to hit my graph one time, right? Now I know that kind of the line kind of looks like it stops. So remember, that is a line that goes kind of forever and ever, right? Okay, so first thing we're going to say here is, yes, we have a function, okay? Now, the next thing we need to figure out is what is the domain and what's the range, okay? So remember, the domain, y'all, refers to the x values, and the range refers to the y values, right? So when I'm trying to figure out the domain and the range, and I just have a picture, like I have a graph, the idea is if this is my x-axis, right? So the idea here is if you were to pick any point along, let me do it in red. If I were to pick a point anywhere along the x-axis, if I pick this point, I'm already hitting the graph. And obviously, if I pick points to the right of this one, if I go down, I'm going to hit my graph. And if I pick points to the left of this one here, if I go up, at some point, I'm going to hit my graph. And that's going to be true no matter how far to the left I go or how far to the right I go because of the shape of this line, the way this line is it goes on and on forever, right? So then what we would say is our domain is what we call all real numbers, because no matter what number I pick, and the way I write that is everything from -infinity to infinity. Again, if I think about my number line here, my x-axis, as I move further to the right, I approach infinity. And as I move further to the left, I approach -infinity. So the domain is going to be all real numbers. Now I'm going to do something very similar for the range. So the range refers to the set of the y values. So the idea here is if I were to look at this line here, obviously right here I'm already hitting the graph. But if I pick any point lower, no matter how far low I go, if I go to the right, I'm going to hit my graph. And if I go up and I go to the left, I'm going to hit my graph. So my range is also going to be all real numbers. And again, the way we write that is from -infinity to infinity, right? And so sometimes the way we do these is just write them, like this, using this kind of interval notation, right? So now let me take a look at the next problem. So remember, the first thing we're going to figure out is this thing here a function, okay? So first thing is when I draw a vertical line, if you notice, I already hit it more than once. So the first thing we're going to say is it's not a function. Okay? It's not a function there because our vertical line hit it more than once. Now, the second thing we're going to do, we're going to find our domain. So remember, the domain of the x values, right? And so when I'm looking at my x values, I'm going to pick a point along my x-axis. And if I go up, I should be able to hit the graph. So if you notice right here, the smallest point that I can pick and still hit the graph is when I'm at 3. And then every point bigger than 3, if I go up, at some point I'm going to hit that graph because this thing kind of curves like this, right? And it keeps going. But the smallest number I can pick is 3. If I pick any numbers smaller than 3 and I go up or down, I'm never going to hit my graph, right? So what we would say for our domain is we're going to pick the values of x so that x is bigger than or equal to 3. Okay? And one way we can write this using interval notation, y'all, is with a bracket 3 all the way to infinity. So remember, when we have the equal to part, we use a little bracket. Okay. Now, let's do the same thing for the range, right? So if I want to find the range, now remember what the range refers to. The range refers to the set of y values. So if I pick any point over here and I go to the right, at some point, I should hit this graph because it's going to kind of do this number, right? So no matter how high I go up or how low I go, I'm going to hit my graph at some point, right? So again, here I would go from negative infinity to infinity because I can pick any point along my y-axis, and that's going to be true as well. Okay. Alrighty. So now let's take a look at this next one here. And we're doing the same thing, right? So first, let's figure out if it's a function. Every time I draw a vertical line, I'm only going to hit my graph once. So yes, we have a function. Okay. Now, let's see if we can find our domain. What the domain says, pick a point. And if you either go up or down, you should hit your graph. Now remember, this line does this, and that does that. So every time I pick a point, if I go down, or if I go up, or if I stay right there, I'm always going to hit my graph, right? So my domain here, y'all, is going to be, again, all real numbers, everything from negative infinity to infinity. Okay? And then we can do the same thing with determining the range. Okay? So remember, the range says, let's pick a point on the y-axis. If I go to the right, I'm going to hit it. If I come over here, I'm going to hit it. And no matter how high or how low I go on that y-axis, I'm going to hit my graph, right? So my range is still going to be everything from negative infinity to infinity. Okay. All right. So for the next couple of problems I got here, we're evaluating functions, okay? So guys, evaluating functions, I always call these problems plug and chug, because all we're going to do is take our value and plug it in, right? Okay, so let's take a quick look here. Here's my function f of x, and it's equal to negative 3x plus 4, and I'm finding f of 0. So the only thing I'm going to do here, y'all, is everywhere I have an x, I'm going to plug in the number 0, right? Okay, so let's see. Negative 3 times 0 is 0, plus 4 is just 4, right? And we're going to do the same thing here for this next one. So I'm going to come back to this function right here, and everywhere I have an x, I'm going to replace it with the number 1/3, right? So I have negative 3 times 1/3 plus 4. So guys, these 3's here will cancel, and so this is going to give me negative 1 plus 4, which is equal to 3. And so the next one is f of p. So again, all I'm going to do, I'm just going to rewrite my function down over here because I'm kind of missing it now. So negative 3x plus 4. Okay, so now if I'm going to find f of p, all I'm going to do is everywhere I have an x, I'm going to replace it with the letter p. So negative 3p plus 4. And I'll do the same thing right here. So I'm going to come back to this function. And everywhere I have an x, I'm now going to replace it with a negative x. So we're going to put negative 3 times a negative x plus 4. And so this is going to give me a positive 3x plus 4. And then we got one last one. f of x plus 2. So again, I'm going to come back over here, and everywhere I have an x, I'm going to replace it with an x plus 2 plus 4. And so this is going to give me negative 3x minus 6 plus 4, which is just negative 3x minus 2. And I think, okay, yeah. So we got those done. So guys, again, before I go on to anything new, how did those last few problems seem? Are they easy breezy cover girl, or are they tough to do? What do you guys think? Anyone have any questions so far? We're good? Okay, just checking with you guys. All right, so guys, let's take a look at the next problem here, and fairly easy. Good, good. I'm glad it's working out so far. So let's take a look here. So guys, for the next problems, it says for each function, find f of 2 and f of negative 1. So let's go ahead and do that. So what I'm going to do here is, when I'm trying to find f of 2, what that means is I'm going to go to my function f, and I'm going to look when the x is equal to 2, what is the y value going to be? So I'm going to come back over here. Here's the x value. When x is 2, y is also 2. So I'm going to say f of 2 is equal to 2, because that's the y value when the x value is 2. Okay. When I do the next one here, f of 2, so I'm going to come over here to 2. 2 is hooking up with 15. Okay. And I also need to do this for f of negative 1. So let's do f of negative 1. So I'm going to come back over here. Negative 1 is 3. Okay. And then right here, f of negative 1 is 10. Okay. Let's do the same thing here for this next one. So we want to find f of 2. So I'm going to come along to the x-axis right here, guys. And I'm going to scroll along right here. When x is 2 and I go up, what's the y value that we're hitting? We're hitting 3, right? And then if I'm going to do the same thing, f of negative 1, what I'm going to do is I'm going to come along here to the x-axis at negative 1, and I'm going to go down. And what's the number we're hitting there? Negative 3, right? So that's basically how I'm doing these problems here. It's kind of like a stare and compare type of thing, right? Look at the values and see what we're coming up with. Okay, so guys, now that we've done that problem, I'm going to ask you all a couple of questions. Okay. So let's see here. Looking at the picture, does anybody know what is the value of f of negative 2 just by looking at the picture here? Anybody know what f of negative 2 is equal to? Zero. Very good. Boom, got it. Awesome. Okay, so guys, right here we're going to put 0. Okay. What about f of 0? By looking at the picture, what would you guys say f of 0 is equal to? Anybody know what f of 0 is? If you look at the picture, there you go, guys. You got it. Perfect. 4. Good. Excellent. Okay. And let's do the next two. What's f of 1? F of 1 is 2. Perfect. And then finally, what's f of 4 going to be equal to? There you go. Perfect, guys. So you guys got this. I had no doubt that y'all knew what was going on. Perfect, perfect, perfect. Good, good, good. Okay. So that's 2.3. So guys, the next section I have here is 2.4, linear functions. And it says a function f is a linear function if for real numbers a and b, f of x equals ax plus b, and a is not 0. And the domain and the range are both going to be everything from negative infinity to infinity, right? So at this point, my guess is you guys have a lot of experience graphing lines, right? So typically, I know here it says f of x equals ax plus b, but if you guys remember, this is probably a form or formula that you're pretty familiar with, y equals mx plus b. So guys, remember, y and f of x mean exactly the same thing, right? It's just now we're writing it using something that we call function notation. But the idea is they're both the same, okay? And so it says graph each linear function, give the domain and the range, identify any constant functions. Okay, so I'll explain that part in a second. We already know what the domain and the range are, right? The domain and the range are both all real numbers, negative infinity to infinity. Okay? Now, if I think of this form y equals mx plus b, right? Or remember, m is the slope and b is our y-intercept. And I look at the function that I have here, right, which is f of x equals x minus 4, then I can say, well, you know what? My slope here is 1 over 1 because it's the number in front of the x. And my y-intercept is the point 0 and negative 4. So all I'm going to do is, remember, my y-intercept always has an x-coordinate of 0, you guys. And then whatever that number is going to be the second number here. And that's always going to be my starting point. So I'm going to start down here. And then if my slope is 1 over 1, I can just move up 1 and over 1, up 1 and over 1, up 1 and over 1, up 1 and over 1. And there's our line, right? So let's take a look at the next one. And I'll go ahead and do the same thing here, right? So if I do a little stare and compare to y equals mx plus b, right, then I know that here my m is 1 over 2, and my y-intercept is 0 and negative 6. So again, remember what that means I'm going to do? I'm going to start down here, and since my slope is 1/2, I'm going to move up 1 and over 2, up 1 and over 2, up 1 and over 2. And again, there's my graph. My domain, one more time, guys, is negative infinity to infinity. And so is our range, right? All right, so let's try the next one. It's the same type of problem, right? So one more time, if I come back to y equals mx plus b, and I look at my function that I have here, I know that my m is negative 2, and if there's nothing there, my b is going to be 0, right? So I'm going to start right here, and I can think of this, guys, as negative 2 over 1. So remember what that means. I'm going to go down 2 and over 1, down 2 and over 1, right? Down 2 and over 1, and here's my graph, right? Okay, let's see. All right, so the next part I got here, y'all, is the slope of a line. So again, at this point, the fact that you guys are taking college algebra, I'm sure that you guys have seen the slope of a line before. And here's our slope formula, right? And again, guys, a lot of these formulas, again, I just call them plug and chug type of problems because all we're going to do is plug our numbers in and we're going to go ahead and chug along, right? So remember, I can think of this first one as my x1 and my y1, and this one's going to be my x2 and my y2. So here's my formula. It's the same formula that I have right here, right? And again, all we're going to do is plug and chug. So y2 is the number negative 8, minus y1 is 4, and x2 is 2 minus a negative 3. So minus 8 minus 4 is a minus 12. And this becomes plus. That's going to give me a positive 5. And so there's our slope, right? Okay. And so I'm going to kind of skip over the next ones because, again, I know that you guys know how to find the slope of the line. Let's see. Okay, so one thing I want to mention, guys, about slope is when our line is going up like this. And the reason I know that line is going up because I always read a line, guys, going from the left to the right. So that line is going up, our slope's going to be positive. If our line is going down like this one is, then our slope is going to be negative. If we have a horizontal line, the slope is 0, and if we have a vertical line, then the slope is undefined. Okay. And so for this next problem that I have over here, it just says graph the line passing through the given point and having the indicated slope. So remember, first thing I'm going to do, y'all, I'm going to go ahead and plot this point. So the point -1 and 3 would be 1 to the left and up 3. Okay. And there's my starting point, right? Because that's the point that I know. And then since my slope is 3 over 2, I'm going to count 3 spaces up. 1, 2, 3, and over 1, 2. And there's my line, right? And we'll do one more. So let's go ahead and try this next one. So my point is -2, -3. So -2 and -3 is down here. And then my slope is -3 over 4. So I'm going to count down 3. 1, 2, 3. And then 1, 2, 3, 4. All right. And there's our line. Okay. Alrighty, so let's take a look at this next part here. And let's see if we can't figure this out. And it says a firm will break even, so there's no profit and there's no loss, as long as the revenue equals the cost. And it says the value of X, the number of items produced and sold, where C of X equals R of X, is what we call the break-even point. Let's see. Assume that each of the following can be expressed as a linear function. And it says, let's find the cost function, the revenue function, the profit function, and the break-even point. Okay, so first thing we're going to do here, we're going to see if we can find the cost function. Okay, so the cost function, we call it C of X. So the fixed cost, y'all, means that's going to be the amount that we're going to spend regardless of how many items we produce, whatever it is we're making, okay? So we already know we're going to spend $500. And then for each item that we make, it's going to cost us $10. So my cost function is going to be C of X equals 500 plus 10X, okay? Now, let's see if we can find the revenue function. Okay, so the revenue function, we use R of X. So revenue means how much money are we going to bring in? Well, for every item that we sell, we charge $35, right? So 35X is going to be our revenue function. Okay? Excuse me. And then we have something called the profit function. So the profit function is going to be the revenue minus the cost. Okay? So it's going to be 35X minus 500 plus 10X. Okay? And the profit function P of X is going to be equal to, let's see, 35X minus 500 minus 10X. So I'm going to write it more over here. So the profit function is now equal to 35 minus 10 is 25X minus 500. Okay. All right. So we got that part. And then there is a part D. And it says, find the break-even point. Okay, so guys, it says the break-even point is when the cost function is equal to the revenue function. Okay, so all I'm going to do here is I'm going to set this equation equal to this one. So 500 plus 10x is equal to 35x. So I'm going to subtract 10x on both sides, and then divide everything by 25. Okay. So again, if I take my calculator here, y'all, and I take 500 divided by 25, what are we coming up? We're coming up with 20, right? Okay, so we came up with 20. That's the number that we have to sell, right? And when I look at part D, it says find the break-even point and decide whether the function should produce given the restrictions on sales. Notice what it says. No more than 18 units can be sold, so we can't sell more than 18. And in order for us to break even, we need to sell 20. So right here we would say, let's don't produce this thing, whatever it is, because for whatever reason they gave us this restriction, and we have to make and sell 20 in order just to break even. We'd have to make more than 20 or sell more than 20 to get a profit, and they're telling us we can't sell more than 18, right? Alrighty, so guys, this one here, same type of problem. Notice there's no restrictions. So I'm going to stop right there, and I just want to make sure what we did today. Let's see, let me do this. Let me go like this, and here we go. Okay, so what we did today, did this seem to make sense, at least for 2-3, and for, I know we didn't do every single problem out of 2-4, but I'm assuming that you guys have some experience finding slopes and stuff like that and drawing lines. Did any of this stuff today make sense? Yeah, okay. Okay, so guys, you guys look like you guys are really on track with a lot of this stuff. I know you guys are a dual enrollment class, so this is really good because sometimes when I teach my traditional college algebra, and I've had people who've been out of school for a long time, they struggle with some of this stuff, but you guys definitely seem to be on top with this. We'll go ahead and call it a day right here, guys. Remember, all this stuff, all the videos are there on YouTube, and what I'm doing with here, you guys, what I'm doing here with y'all, it's the same thing that I have on YouTube, right? And I talk y'all through the process. So I'm hoping that you guys are finding the videos helpful. At any point in time, guys, if you guys got questions, let me know. My other classes are asking me questions left and right. I'm making little videos for them. So don't be shy about asking me anything. I really am happy to help you guys. I want to make sure that you guys do well. And then just a friendly reminder, guys, that we do have our midterm next week on Monday and Tuesday. You obviously only need to pick one day, guys, that works best for you guys. So Monday, I think we have ours at 10:30, and if you prefer Tuesday, we have it at 6:30 in the evening. I try to give you guys some options in case any of you guys have jobs for the summer or whatever. I want to make sure that, you know, I can work with your schedule. But anyway, we'll go ahead and call it a day there. I'm going to stop recording the session.